All right, it's time for us to talk about video parameters and kind of explain them in a way. Um, as you can see, there are 5 basic parameters: frame rate, resolution, aspect ratio, and pixel aspect ratio, and compression. These are the elements that basically affect all the aspects of your video. So you need to know what they are and where to find and how to identify them. So frame rate first, resolution, aspect ratio, pixel aspect ratio, not the same as aspect ratio, and compression. These are the 5 elements you need to worry about. So that's what we're going to be talking about. So let's start with how to find out where these are. In Premiere Pro, you can right-click on a source clip and go down here to Source Settings, and then you will find this window will come up. This is for a particular clip, and you'll see that it's showing frame rate right here. It's showing resolution on the next slide. So there's the image size or resolution. Aspect ratio also has to do with the left and right. This is 16:9 aspect ratio. The pixel aspect ratio is whether it's a square. Aspect ratio 1 means it's square. And compression, the form of the codec that's used to compress the file. So that's how we get to the 5 parameters. All 5 parameters are specific settings of each component for each video you have. So it's vital as an industry professional that you understand all of the concepts behind these. When you're creating video, you have various elements that come in and feed the final video, and you have to have all of these things set up correctly to get the right outcome, or consistent outcome. So first, let's start with frame rate. Frame rate's fairly easy to see. It's written as frames per second. 16 and 35 millimeter film, the standard is 24 frames a second. NTSC, which is America's national standard, is 30 frames a second. So a little bit about frame rate. How do you know what frame rate to use? And why is 30 frames per second actually runs at 29.97 frames per second majority of the time? Now, an actual movie camera runs at exactly 30 frames a second, but the digital cameras do what's called a drop frame time code. So a little bit about drop frame. If you look at the sequence, after a certain number of frames, you will outrun the audio. So the audio sync will come out of place somewhere around a minute or so, but it gets really noticeable 4 or 5 minutes down the road. So what they do is they don't drop frames. That's not exactly the term. They skip frames. So you're going along and you get to frame 02 here, and they'll skip a frame every minute or so, except for every 10th minute, to keep it in alignment with the audio and video lined up. So 24p or 24PA stands for progressive, and that's 23.98 for 24 frames a second drop frame. Animation video games come out a standard 60p, playing back with drop frame being 59.9, and European standard 25 frames per second. Now, 2 concepts you need to be aware of with frame rate. One is interlacing and one is progressive. I just mentioned progressive earlier. Interlacing is the old style of working where the file would be interlaced with the odd channel and the even channel, and then they would be recombined in broadcast. This was because for broadcast television, they couldn't broadcast this whole symbol, so they had the camera breaking apart the image into strips. And that's the way that back then the cathode ray tubes displayed. They displayed with lines of data. Interlace has actually gone out of favor recently. It's not really used anymore, but you might still come across interlace material, and you might need to delace it or deinterlace it. If you look at this graphic, interlaced every other line. With progressive scans, you have a whole image for each frame, just like you would with a camera, taking a whole frame onto film. So that's why we call what we do today progressive. It used to be a modern thing to be able to get a camera that photographed and filmed in progressive, other than the film cameras. But now pretty much all of your cameras do that. Okay, so now we move on to resolution. Resolution has to do with the height and this length of your pixels. So standard definition, or SD, is 48 by 720. That's small, but that's what all video used to be at. We don't have to worry about the European standard, but here the HD video, what's called high def, is one of these two, usually 1920 by 1080, and it has a particular aspect ratio we'll talk about. 4K videos come in these different flavors, 21.60 by 3996. This one's 7, and these are all specific to different cameras. Each different camera might have a different amount of close to 4K, but anything close to 4,000 pixels they call 4K. Now, of course, we have 6K, 8K cameras, and who knows where that's going to stop. It's pretty impressive. What's the advantage of resolution? Well, down at DV or 720, you're getting this many pixels for your information. With 2K or HD video, you're getting this much. Look how much more data you get in 4K. That is a huge amount of more data captured. And the advantage of that is it just gives you a better image. More detail, more to work with in special effects, that kind of thing. So aspect ratio. Aspect ratio is the shape of the frame, the proportions of the height and width. It's similar to resolution, but aspect ratios can vary greatly and can be completely independent from resolution. With this example, you can see a 1:1 aspect ratio, a 4:3, which is standard def TV, 16 by 9, which is HD TV, or 1920 by 1080, for example. But 16 by 9 is just the aspect ratio of the two numbers against each other, the height and the width. And down here is a cinescope, 2.35:1. So this is a much more dramatic scope. So if I show you what these look like, so like a 75 or 35 millimeter cinescope might be this 2.35:1 that I showed earlier. Let's move on to some examples. So classic TV is 3:6, 4:3. Our TVs today, modern digital TVs, are 16 by 9, and then there's lots of different widescreen variations, and of course there's anamorphic we'll talk about in just a minute. So here's a standard def representation from a film, Loving Van Gogh, where they kind of it's actually animated, but they reproduce Van Gogh's paintings, and it's a 4:3 aspect ratio. And then here's more of a HD standard. This is 1984. And it's a 16 by 9 anamorphic. And then here's more of a cinescope feeling. This is Scorsese's film, Silence, I think it's called. And so you see the longer, narrow scope of that. The cinescope has been popular with theaters that have wide screens like this. And let's move on to pixel aspect ratio. Now, what the heck is pixel aspect ratio? Pixels are usually square, aren't they? Well, not always. They're not always. We get squeeze more data in vertically or horizontally in the frame. And so lots of old video cameras, for example, would have horizontal pixels. Well, now this is a pixel, it's square. This is a 1:1 pixel aspect ratio. And so the pixels are simply picture elements, the tiniest part of what describes an image. But if we squeeze more data vertically or horizontally in, we can get more data in. So if you see, here's it squeezed narrower, right? And here's it regular ones. So down A is regular squares. B is these narrow ones squished together. But then if you take those back out to a square, all of a sudden that circle gets stretched, which is not quite what you want necessarily. But if we move into anamorphic, you can see that an anamorphic lens squishes it like this on the left. And then in the computer, you unsquish it or you stretch back out to horizontal pixels, whereas these are all tall and narrow pixels. So anamorphic is a very popular style. It gives great bokeh. See the shape of the out of focus areas? But it gives a big wide screen. Also, it has crazy lens flare. So it's known for its interesting, unusual lens flares because the lens actually compresses the file quite a bit. Lots of this horizontal action going on. So if you like lens flare, that's one of the things you'll like. Okay, so that's pixel aspect ratio, different from aspect ratio. So now we move into compression or codec, which is compress, decompress. So which codec should you use? Which kind of compression should you use? Well, I have a whole nother lecture just on codecs, so we'll deal with that later in detail. But for now, what you need to know is that you have original footage captured. To get it even out of the camera and record it onto a card, you have to put it through a compression. So video compression, audio compression, it gets encoded into a video file where the video and audio are combined together. Then to view it, you have to decode it. Take the video footage through the codec, and remember codec stands for compression, decompression, and back to playback. So that's the basic work of compression. Compression makes it possible to transfer large images, to put things on the web and YouTube and that kind of thing. Without compression, we'd be, particularly with 4K, 6K, 8K material, we'd be in big trouble. So, common compression codecs is standard def NTSC, MPEG-2 for DVDs, H.264 is what I use most of the time for web delivery, and Apple ProRes is an example of an editing codec, and we'll talk about this in more detail later. But it's a fairly high quality, very little amount of compression, and then there's, of course, uncompressed video, which is animation code or uncompressed, but that's going to make a huge file. So here we got frame rate, resolution, aspect ratio, pixel aspect ratio, compression, the 5 things you need to know about your files. And there you go, video parameters explained. I hope you enjoyed yourself.